Alright guys, we got our warm-up here for 4.8. We're going to kind of we have two more lessons for this section, for this chapter I should say. 4.8 is the last one where we're really kind of dealing with, or focusing mainly on proofs. So we have a couple different concepts here. Notice the title's coordinate proofs, so it is going to be a little different than what we've been doing. So again, just take a minute, do this warm-up. We're going to be using these concepts in this lesson, so make sure you understand them so you can pause the video and play it back when you're done. Okay, so first example here, we have find the midpoint. So we have to know our midpoint formula between these 2 points. So if I come up here, I'm going to use our midpoint formula. As a reminder, the midpoint formula, again, the way I like to remind you to remember the midpoint formula, think of it as it's the average of the x's and the average of the y's. So if I'm going to find the average of these x values, that would be the point in the middle. Like if I had the point 4 and 8, the point in the middle is 6. It's the same though as going 4 plus 8 over 2, finding the average of those two numbers, because 12 over 2 is 6. Okay, same concept here, so we're going to do that. And this is an old concept, right? But we're going to go ahead and find the midpoint. I'm going to go 0 plus 2y over 2. That's your x values, average of your x values. Now find the average of your y values. I'm going to go 2x plus 2z. So 2x plus 2z divided by 2. And we just need to simplify this. So this just becomes 2y over 2. And again here we still have 2x plus 2z over 2. Actually, before I write that, I want to kind of talk about something from algebra that we can do as well. Helps you understand this next step, the step I'm going to do after this one, a little bit better. One thing you learn from geometry is factoring, and this is a simple form of factoring where we see that we have a common factor here between my two terms of a 2. I can pull a 2 out of this. This would be like 2x plus 2z. If you divided a 2 by every term, you would get this. This is the opposite of distributive property. It would be 2 times x plus y. So that's kind of what we get here. We have 2y over y, or 2y over 2, and 2 times x plus y over 2. Cancel out the 2's, and we are left with y and then x plus y. So that is the midpoint in terms of your variables for number 1. Alright, number 2, it says one leg of a right triangle is length 12 and the hypotenuse is length 13. What is the length of the other leg? So this would be a triangle such as this guy right here. We have a leg of length 12 and a leg of length 13. Now, if you are aware of the side lengths of right triangles, you would know that the answer is 5. I don't expect you to know that, but I will give you a little hint here of some things called Pythagorean triples. And these are values that if you plug them in for a right triangle, they would all be nice integer values. And some of those values, ones hopefully maybe you've seen before, is a 3, 4, 5 Pythagorean triple. Well, you could do any multiple of that, like 6, 8, 10, or there's some other Pythagorean triples you can use as well. One of which is 5, 12, 13. We have 8, 15, 17. And we have 7, 24, 25. There are some other ones, but these are the most common ones. And if you happen to know these, it's actually going to save you a lot of work in the long run, unless you got to do a proof. But anyway, this would be 5 if you know the answer, but I want to talk about how to actually get it. Okay, so the way you actually get it is you would call that obviously something like a, and we would do our Pythagorean theorem, which is a squared plus b squared, which is 12 squared now, equals c squared, which is 13 squared. So I get a squared plus 144 equals 169. So we subtract 144 from both sides, and that's going to give you a squared equals 25. And if you square root that, you're going to get a equals 5. Or you just know it's 5, right? So number 2 should be 5. Number 3 says find the distance between these 2 points. Now this is just another scenario where we're using Pythagorean theorem. Remember I've been saying this before, so I'll review, right? So if you have these points, you can now label them, but we don't have the triangle drawn. They gave us points instead. So what we can do here is we can just label our points using the xy axis. I'm going to call this point right here 0b, and I'll call this point, I don't know if it's a scale or not, but whatever, I'll call that let's see, find the distance between, oh, I'm using the same, it's on the y-axis, sorry. We'll be going to that other point here in a little bit. So let me go back. Goes okay. Sorry, these are all on the y-axis. My bad. So I'm gonna have 0, 0a, and I'll do a point up here at 0b. I accidentally put that other point in there again, but anyway, we're looking for this distance. Now to find that distance, all we need to do here is actually subtract. The distance between any 2 points in a straight line is just, you got to subtract the 2 values. This is from like one of the first lessons we did on distance. So in this case, the distance would be b minus a equals your distance. We'll get to the point where they form the triangles when we get into the lesson. So that's your warm-up. Those are going to be 3 answers for the warm-up. Make sure you have that work, and we'll kind of move on from there. So let's talk about what we're doing today. Our goals for today, again, you're going to be able to position figures in the coordinate plane, and we're going to use those figures and some of the concepts we know about midpoint, Pythagorean theorem, stuff like that, to use coordinate proofs. You're also going to be able to prove geometric concepts by using a coordinate proof. So it's all about the title of the lesson, coordinate proofs. And in coordinates, we're talking about the xy plane. Okay, so that's kind of what we're going to be doing today, or tonight. So I'm just kind of reading through this slide here to give you some idea of what we're doing. So just follow along with me. So we've used coordinate geometry. We've used that on some of the problems. It's not like this is the first time we've used an xy plane in this class. So we've used coordinate geometry to find a midpoint of a line segment using midpoint formula, and to find the distance between 2 points using Pythagorean theorem or the distance formula. Coordinate geometry can also be used to prove conjectures. That's what we'll be doing now. This is, again, just an introduction to it, but I'll give you the idea. So coordinate proof is, again, a style of proof, not like a 2-column proof, that uses coordinate geometry and algebra in conjunction with one another. So the first step of a coordinate proof is to position the given figure in the plane. So we'll draw it, and I'll talk about how to draw it as we do it. And you can use any position, but some strategies can make it a little bit easier. So that's, again, something I'll be telling you about. Okay, so these are some of those strategies. So as we kind of go through here, you'll see we want to use the origin as a vertex. Why not? It's the easiest point, right? You don't want to start from 0 instead of starting from like -7, -3. That wouldn't be fun. So use 0 if we can put a figure anywhere we want. So we'll center that figure. Also center a figure at the origin. I'll show you that as we go through. You can center a side at the origin, especially with right triangles, you'll see that. Or you can use one or both axes as sides. And again, a lot of these ones that I'm telling you about are like if you have an xy plane, you can use the origin as a starting point. Just center your figure there. You just, like, say I had a right triangle, I can use the sides as well to help make it easier for me to draw my figure. Okay, so anyway, there's just a couple examples. I mean, you can honestly, when you do these proofs, you can put the figures anywhere you want. So just put it in long story short, put it in the position that you feel will make the math as easy as humanly possible. I know most people don't want to challenge themselves just for fun. That's only something I do, not you, unless you want to be like me. All right, so example 1, it's just simple, just kind of getting figures drawn correctly. So example 1, we're just going to position a right triangle with legs of 2 and 4 in the coordinate plane. That's all we're doing. So it's about kind of just showing how we label these figures. So example 1, just a quick little drawing here. Now here's what I like to do. Use the first quadrant. That's the first thing. Why? Because it's easier. Everything's positive, you know. So it's going to have leg lengths of 2 and 4. So I'm going to kind of go out here 1, 2. Let's go right 2, and I'll go up 1, 2, 3, 4. I'm going to use my legs at 0, 4, and 2, 0. And I'm going to draw my triangle using my axes as my sides and my origin as my right angle. So this would be my triangle, and I can label it. It's 2 and 4, and I can do 2 squared plus 4 squared. This is not a Pythagorean triple. And I can find that third side. It's not asking me to, but I'm just going to do it. So that'd be 4 plus 16, so c squared equals 20. Now if I was going to simplify that, c, if you square rooted both sides, this becomes the square root of 4 times the square root of 5. If I'm simplifying my radical, well, if I'm simplifying this radical, you should know that the square root of 4 is actually 2. Square root of 5, however, you can't really simplify, so this would be our hypotenuse. Again, the question is not asking for it, but it's a math, a chance to do some algebra, and I'm going to do it. Okay, and it's something that's a portion of math you need to know. You need to know how to simplify radicals. It's kind of important. But anyway, there's your figure, and actually it's all your sides as well. So moving on, that was all that example really wanted. So once we have that figure, that's all the first example was, is how to place it. You can use slope. You can use the coordinates of the vertices. We can use there's some big ones here, the distance formula or Pythagorean theorem. I'm going to kind of put that off to the side. Distance formula, aka Pythagorean theorem. Or the midpoint formula. We'll be using that one a little bit as well. You'll see us use that a lot to prove statements about the figures. But again, just make a little cheat sheet for you of the things that you can use on these coordinate proofs. You can use slopes, you can use the coordinates of the vertices to find the distance and to find the midpoint. So if you know how to do distance, midpoint, and you know how to do slope, then we're going to be in pretty good shape, aren't we? Okay, so example 2, kind of got a figure to help you out here. So this is the figure from your, the page in your book. So you don't have that in front of you, that's fine. You have it right here. So when you use the information in this figure to write a coordinate proof showing that the area of triangle ADB is 1/2 the area of triangle ABC. Now, one thing that's mentioned in the figure that you're going to need to know is that this is something we need to write down. So put this down. This is a given information. D is the midpoint of AC. That's important information to have. So I have the D as the midpoint, and then I'm going to go ahead and do my coordinate proof. So I'm going to start off, and this is just information you need to know, the area of a triangle. Obviously this is talking about proving that the area one is half the area of the other, so you need to know what the area of a triangle is. So that's just going to be 1/2 base times height. I'm not going over this from scratch like, oh, this is something you've never seen before. You've better seen this before, but if you forgot it, you better remember that. It's kind of basic geometry here. It's stuff you even learned before you take geometry. Know how to find the area of a triangle. So it's 1/2 the area of a rectangle, really. But anyway, we can start by finding the area. So we can find the area. Oops, I should probably write that a little bit better. That's a sentence. So the area of triangle ADB, not ADB, ABC. That's going to equal 1/2 times the base. Now you can kind of look here at the base. They're giving you the base. You can literally, oh, that's not the point. That's the distance on the x-axis. So this is going to be 1, 2, 3, 4. So the base here is 4. So it's going to be 1/2 times the base, which is 4, times the height, which goes up to 6. So that's going to then equal 2 times 6, or 12 units squared. So I have the area of that triangle. Now, what they're doing here is they're saying D is the midpoint of AC. This is important just in the very sense to make sure we know where that point D is located. So especially if they don't have that point labeled, like if that wasn't given to you, they just said there's a D out here, it's the midpoint of AC, part of the proof is showing where that point is. So we know, we're not assuming, that point's at 2, 3. We're proving that that point is at 2, 3. So I'm going to go ahead and do that. So I'm going to find the midpoint of AC. So in order to do that, I need point A, which is at 0, 6, and I need point C, which is at looks like 1, 2, 3, 4, 0. So I'm going to go ahead and find my midpoint. Remember the midpoint. Actually, I'm going to say, well, yeah, that's fine. I'll say M equals, but it ends up being D, but M stands for midpoint. That's going to be the average of your x's, so 0 plus 4 over 2, and the average of your y's, so 6 plus 0 over 2. So that's going to equal, looks like 4 over 2, which is 2, and 6 over 2, which is 3. So I can label that point now as 2, 3, which makes sense. It looks like that's where it was, and that is exactly where it was. But there's no telling if that would be, 2 and 3.1 or something, or 2.1, 3.2, or something really close to 2, 3. But I've just proved that it is currently at the point 2, 3. Because of that, I can then find the area now. So from here, we can find the area of triangle ADB. And again, that's going to be 1/2 base times height. Now in this case, I'm going to call this side my base and that my height. You can see the right angle that's formed. So the base here looks like it's going up to 6. I'm going to go that's 6 for my base. My height, I'm going to 2. Again, you're going horizontally to get that height. So I'm going to use 2 for my height. Think of that as my 2. My base is 6. Okay, that's your base, that's your height. It's just a triangle sideways. So if you multiply that out, half of 6, or actually half of 2 is 1. So 1 times 6 is 6 units squared. So what we're trying to do here is prove that the area of triangle ADB is 1/2 the area of triangle ABC. So therefore, actually we probably need to say one statement before I say therefore. That'll erase. So we know that 6 is, I'll write it out with numbers. So we know 6 is 1/2 of 12. Therefore, the area, man, I can't write today. Actually, I was writing right. I just not thinking straight today. Sorry. Therefore, the area of triangle ADB is 1/2 the area of triangle ABC. There we go. I got it. Just give me a minute and I'll be good. So again, we had to show it. We had to show the different areas. We had to prove that D was the midpoint, or they told you D was the midpoint. When they tell you D is the midpoint, you need to apply that concept and use the midpoint to prove that D is at 2, 3. If you prove that, you can do your area. If you can do your area, you can show that one is half of the other. So again, that's all we're really doing when we're doing our proofs. It's just doing the algebra, just showing. It's like showing your work. Just show all your work. That's really all it's saying. If it's a given statement that's telling you I have to use midpoint, so I did it. Obviously, to find the areas of the triangles, you have to find the areas of the triangles. And once you've done that, write your statement. Okay, it's all kind of mapped out for you. So just do what the proof is asking you to do. Apply any given concepts that they're asking you to apply algebraically, and you'll be fine. So there's example 2 for you. Alright, so this is just information here, so again I'm going to keep reading through that to make sure we're all on the same page. So again, a coordinate proof can also be used to prove that a certain relationship is always true. This is going to be using not just numbers, but variables or letters. So you can prove that a statement is true for all right triangles without knowing the side lengths. You can just call them A, B, or X, Y, or things like that. So we're just going to assign variables to those in order for that to work out. So again, here they're saying do not use both axes when positioning a figure unless you know the figure is a right angle. We should know that. I'll kind of explain as we're going through our examples. Okay, so this one just asking you, it's more of a setup for example 4, and we'll finish with example 4. But here we're going to position a square with side length of 4p in the coordinate plane and give the coordinates of each vertex. So I'm going to go ahead, and again, remember, always make this as easy as humanly possible. Let's only use the first quadrant. And here I'm going to draw a square so I know all the sides are the same, and those sides are 4p. So I'm going to come up here to this point and this point. I'm going to use these for 2 of my sides of the square. Since I'm doing that, I'm going to come up here and use this for my last side. Now remember, these sides are 4p all the way around. So you got to think of how you would plot these points if you knew that length was 4p. I'll change the color so we can keep track of it. Obviously this point would be 0, 0. That's our origin. Now to get to the second point, what we would do is we'd go right 4p. That's how far to the right that we would travel. We're not going up or down, so that's going to be 0. Same thing if I was going to this point, except that you're going up and not left or right, so you flip the points around, it'd be 0, 4p. And finally, if you want this final point, understand that I have to go right 4p and then up 4p. Again, follow me again. I'm right here. See my point? I'm going right 4p, up 4p. So that's 4p, comma, 4p. And those would be your points. So again, that would just be a setup that we can use as we're doing our coordinate proofs. And if we have to go a step after that, then we will, which we will. Okay, so it's just more information. If you have a coordinate proof, it requires calculations with fractions. Choose coordinates and make the calculation simpler. Again, for example, use multiples of 2 when you are to find coordinates of a midpoint. Now, that is a big hint because we're going to be doing lots of midpoints on these. So just make sure when you're using your variables, since you know you're going to do a midpoint, if you don't want to deal with a fraction, then call your values like 2p or 4p or something like that. Okay, because remember, when we do midpoint, we're dividing by 2. So we need to have something divisible by 2. So once you've assigned the coordinates of the vertices, the procedure for the proof is the same, except we won't have numbers. So it's just like what we did before, but we're just going to have variables now. It's really, if you've done example 2, you can do example 4. Okay, again, same thing. If x, y, axes intersect right angles, they can be used for the sides, blah, blah, blah. We've done this already. Okay, so in this case, they're kind of giving you the points here, but you can even pretend like these points weren't given. Understand why we're using 2n and 2j. Okay, so if these points aren't given to you, I want you to understand the importance of it. We're going to be doing a midpoint just like we did in example 2. Okay, so same thing as before, where we know that D is the midpoint. You can see that because of the way it's labeled of AC. Now, anyway, it says we're using example, or use information example 4. Here it is. Okay, to write a coordinate proof showing that the area of ADB is 1/2 the area of ABC. Again, this is exactly the same problem as we did for example 2. Same work. The only difference is we have letters this time, or variables, instead of numbers. So I'm going to start the same way. The area of triangle ABC. Find that area first. Now again, what's different? Well, the difference is I'm not going to get a number. I'm going to get an answer with variables in it. So all I need to do is find that area, and then I'm going to do my midpoint. I'm going to find my second area. And once I do that, I should be able to see that these expressions, one is half the other. If you don't know how that could ever happen, how I could ever tell, I'll show you once it's in front of us, okay? But let's find the area first. So 1/2 base. Well, what's the base? Well, the base is the length from here to here. Now if you look here, I'm going from 0 to 2n. So if you want to figure that out, that length is 2n. That's how far I'm going. So that's my base. It's 2n. My height, I'm going from 0 to 2j. So that height is 2j. So that's my height. So this ends up equaling half of 2 is 1. So I have 2 times nj, so 2nj. That is going to be my area of triangle ABC. Next, let's find the midpoint. So the midpoint of AC. Let's do it. So that's going to be m equals the average of the x's. So look, I'm doing these points, 0, 2j, and 2n, 0. So I'm going to add my x's. So 0 plus 2n over 2. Now I'm going to go, oops, I'm going to add my y's. So 2j plus 0 over 2. 2j plus 0 divided by 2. Simplify this out. I get 2n over 2 and 2j over 2. And that equals n comma j. So I now have this point. It's n j. So if I'm going to find my area, remember how we're going to do this. I'm going to use this as my height. Well, what's the height? Well, look, it's going from here to D. So you look at this point, that distance is n. That's how far right I am traveling. See, if I start at 0, 0, I'd go right in. So this distance is n. Now the height is j. Okay, so if you go from this to here, that's j. But if you look, that's not this length. I need this for my base. This is the base of my triangle, whereas n is my height. So this is going to be 2j for my base. It's the same as the original, my original height actually, right? The original height actually becomes my base. So this is the base of your triangle. This is the height of your triangle. The base has to form a right angle with your height. So in that case, that'd be 2j. So that's going to be my next step. Since I'm using that point now I can find the area of triangle ABD. So it's going to be 1/2 base, which is 2j, times my height, which is n. So that becomes half of 2 is just 1, so that's j times n. Now hopefully here you can see that I had 2jn. Here I just have jn, which is nj. So as you should hopefully see, that's half, right? This is half of 2nj. So I can say that nj is 1/2 of 2nj. Therefore, the area of triangle ADB, am I doing that right? The area of triangle, ADB is 1/2 the area of triangle ABC. There you go. There's your proof. Notice it's the same as example 2. The only difference was I was using variables. Otherwise, it's the same problem. So it's treated the same way. I want to use a similar example because I want you to see it's the same math. You're just using letters and variables instead of numbers. Don't treat it any differently though, other than that. Okay. So that's your introduction to coordinate proofs. It's basically what I want you doing. So we got a quick lesson quiz. First 1 and 2, just place these figures in the coordinate plane. Okay. Remember, first quadrant. Use that quadrant. And you can use your axes if you have a right angle in your figure, which we do here, a rectangle and a square. So that should be pretty quick. And then we have a quick proof that we're going to do. Just follow the same types of instructions that I did in the proofs that I did in the notes. Approach it the same way. If they're giving you a midpoint, you need to calculate that midpoint. So make sure you're using that as part of your steps. And then don't forget you can do reflections. So make sure you do your reflection for Mr. Patrick, not for Miss Moore. Okay? Go ahead and give that a shot, and I'll see you guys in class, all right?